Godot built-in trails are quite a bit limited, and they also won't work for mobile or web projects. So today, we'll see just how easy it is to implement our own trails. Start by adding a mesh instance 3D node, and create a new plane mesh. This is going to be our trail mesh. Then, increase the subdivision depth. This is how many bendable sections your trail is going to have, so increase this for longer, smoother trails. I'll set this to 8 for now. Then I'll rename the node to Trail3D and add a simple script to update the trail mesh. There are several different ways we can update the trail. But first, let's make this a tool script so we can see the trails update inside the editor. We'll then add a max point variable for how many points we want to keep, and a position history array to record them. Then let's create an update max points function to initialize the array. Here, we'll set up the max value and pass the values to our shader. Then, let's create another function to make sure our array stays the correct size. If the array is not the correct size, we'll call positionHistory.resize and then use the fill method to initialize them to our current position. Then let's just make sure to call it after we update the size, and also call it in the ready function. And the process function is also very simple. We just need to update the positions to the array. You can add a new position point at the start with positionHistory.insert0 and remove the last point with popback. And finally, we'll pass the position information to our shader. And that's all we have to do for the scripts. Now, we can improve this a bit by adding an export range to our max point. That way, we have a nice scrolling bar to move the points in the inspector. And you can set the update max point functions as a setter, so when we change the value, it will automatically update the array and the shader. And because we use a tool script, let's make sure to reload the scene so everything works properly. You can see the script icon has now turned blue. Now all that's left is to make a simple shader to move this mesh. Let's move it a bit so we can see it, and create a new shader override material. Then, let's create a new shader. First, set the render mode to cool disabled and unshaded, so the trail mesh is displayed properly. Then let's declare a total max points, which is the max number of points we will allow, and an uniform int max point for how many of those we will use to update the mesh. A positions array to store the position history, and a trail width for the size of the trails. The vertex shader is executed for each vertex of the mesh, and here is where we can change its new positions. The first part of the shader is to map the vertex position of the mesh to an index. So we map the uv.y that goes from 0 to 1 to our array size -1. But that is not guaranteed to be a whole number, so we'll make the index its floor value. Let's also save the next and previous indexes. And to make sure the trails update smoothly, we'll interpolate between the current and next points by the fractional value. Next, we'll make sure the trail's rotation is oriented towards the next point. To do that, first we calculate the forward direction with normalize the previous point position minus the next position point. Then, we need a reference up direction, which we can use the global up direction for now, 0, 1, 0, and then calculate the right direction with the cross product between the forward direction and the up direction. Next, we create the width offsets for the trail width, and if you want, you can multiply this by 1.0 minus uv.y. This will make the trails taper off towards the end. But finally, the final word position of the vertex is going to be the current interpolated position plus the right direction times the width offset. And to set the vertex position properly, we just need to get the inverse model matrix and multiply it by the word position. And inside the fragment shader, let's manually set the color albedo to vec3 of 1, 0.3, 0, and orange color. You can also set the alpha to 1.0 minus uv.y to make it fade away towards the end. But let's not use this for now. Now, if we grab our mesh and move it around, we have our trails. We can move them, and it will smoothly follow the node's position. You can change its width. And for this kind of shader, you can use the max points to dictate how long the trails are. But this is not working. Inside the script, make sure the update max points is set in the shader to the correct material, the override material in our case. Now you can change the max points to control the trail's length, and adjust it to your needs. And if the trails get too blocky, you can open the plane mesh and just add more subdivisions. You can set the max points values to be the same number of the subdivisions to get the perfect smoothness for your trails, but you can easily work with less and still get nice results. Now, one problem with the shader is that if we move perfectly up, we won't see the trails. That is because it aligns perfectly with the reference up direction, and there are a few ways we can solve this. But let's also see how we can improve the shader a bit. So let's make it control the trail width with a curve. Add a new uniform sampler 2D curve width to control the trail size over time. But make sure you set repeat disabled and filter linear, or you might get some problems. To make this work, it is as simple as removing the previous width multiplier and multiplying it by the width curve based on the uv.y instead. Now you just need to create a new curve texture, add a new texture, and draw how the trail behaves over time. Another useful feature that is very commonly used is billboarding, and it is also very easy to add. Inside the shader, we can get a camera direction with the inverse view matrix 3.xyz and offset it by the current position. Then, you just need to calculate the right direction using the cross product of the forward direction with the camera's right direction instead. And just like that, the trails now are aligned with the view. And you can even add a new boolean to toggle this on and off. Just use the billboard variable to choose which right direction to calculate with. Another problem you might see is moving very small increments with a bigger size trails. This may make the aligned direction of the trails flicker a bit. So we can change the update script to, instead of logging the positions over time, make it so it only updates after a minimum distance is achieved. And another change you can make is allowing the node's direction to dictate the trail's rotation. This way, you have full control on how it rotates. To do that, you just have to pass the transform instead of the positions to the shader. And inside the shader, you can use the transforms tree to get the position, and the 0, 1, and 2 index to get the right, up, and back directions. And just as an extra, to save on performance, you can use a head index instead of using the insert and having to reorder the array every frame. Just don't forget to update your shaders to use the correct logical index too. But that's it. Like always, if you'd like to support me, you can get the project files and experiments by supporting me on Patreon. Now you can create and customize trails for all your needs. I hope you liked this video, and until next time.